Hello everyone, my name is Fahim, and I have been hearing about data structures and algorithms a lot. When talking about computer science, it doesn't take much for the conversation to move to data structures and algorithms when watching YouTube videos or reading any articles, right? So I decided to research a bit about data structures and algorithms and have at least a top view understanding of what it actually is, right? So I watched a few videos and read a bit about data structure and algorithms, and I'll try to share what all I have understood. So first, let's talk about what data structures are. Data structures are a way to organize data. That's all it is really. And there are many data structures, and I'll talk about a few of them. The first one is an array. It is the most simple data structure. It is when we store data in a sequential manner. And these data, each item has an index, right? So the first one, and arrays are zero index by the way, and in which the first element is at 0, the second element is at 1, and so on, and like that. And this was confusing for me when I first began programming, because everything's index is actually -1 of its actual um, human logical index, right? And so that's how the arrays work. And if one drawback of an array is, if you create an array, for example, with 3 elements, and you want to add one more element at the end, to do this you would think that you just have to add the element at the end of the array. That's it, right? That's all there is to it. But what if the memory location of this fourth item is actually used by some other program, some other data, and we cannot just delete the data and put in our new element, because what if this data is being used by some other program? So what is actually done under the hood when we append an element into an array is, the element is a new element is created at some other new location. Now when we talk about small data structure, small arrays that have maybe like 10 or 20 elements, this is not a big deal because it won't take much memory. But when we're talking about big data that have like thousands and tens of thousands of elements, then deleting and then creating the whole array at a different location is not a really good way to do it, because this would take a lot of memory, right? So this is the main drawback of arrays. And linked list, the next data structure, is what came in to address this drawback. In linked list, the elements can be anywhere in the memory. So if you have the first element here, you could have the second element here, the third element here, and so on. And how these elements are connected is, the first element would have a pointer to the second element. A pointer is uh, a value that represents a memory location, alright? So the first element would have a pointer that would point to this memory. And when we follow this pointer, we can reach the second memory, and the second memory would have the pointer to the third memory, and so on and so forth. Now when we want to add a new element into the linked list, it is much easier, because we just have to change the pointer of the last linked item to point to the new element that we want to add. We don't have to completely create a new linked list. We just have to modify one of the pointers. But this also has a drawback, because searching through a linked list is pretty slow. Let's take the case where we have 100 of elements in a linked list. If I wanted to find the 50th one, in the case of arrays, we could just go to the index of 49, right? So, but in the case of linked list, to reach the 50th element, you have to start at the first element, because the linked list starts at the first element and it points to the second element, then you have the third element, then you go to the fourth element, the fifth element, and so on and so forth until you reach 50. This is really slow. So this is the drawback of linked list. But in the case of linked list, adding and deleting an element is really fast, but searching for an element is pretty slow. Now we have something called hash maps. And hash maps are, if you know Python, it is the dictionary the dictionary type in Python. And it's almost like the objects in JavaScript, but you don't have any methods or functions that are inside these hash maps. Hash maps are just key value pairs. So they're almost like arrays because the arrays have indexes, right? But in the case of hash maps, all of the elements have a key, and the elements itself are the values. So a hash map is a key value pair. Let's take the example of storing the capitals of countries. All right, if you wanted to do this with a hash map, we could do this with the keys as the country name and then the values as the capital of the country. So searching through a hash map is very easy because each element has a unique key. Another data structure is the stack. The stacks are a data structure which follow the LIFO principle, that is last in first out. Stacks are basically, as the name suggests, stacking things and then removing things from the top of the stack. Let's take an example. The stack is a data structure which are basically like plates. Okay, when you're storing plates, you store them one on top of the other, and when you take a plate off, you take it off the top, right? So the last one that came, that is the one on the top, is the one that gets removed first. That is the last in first out principle. Another data structure that is very similar to this is the queue, and the queue follows the FIFO principle, that is first in and first out. The example for this would be, for example, waiting in line at a bakery to order. The first person that comes to the bakery is the first person in the queue, right, in the line. So the first person is the one who gets to order first, and he gets his order and he leaves first. That is, the first one in is the first one out. That is the queue data structure. And there is also maps and graphs and trees, which I won't be really talking about. And I didn't talk about algorithms in this video. I will talk about it in a later video. So that's all from me. Thank you.